open-weight model releases and frameworks. The promise of extreme model compression continues to collide with the stubborn reality that neural networks don't compress gracefully. Multiverse Computing's Hypernova 60B arrived this week claiming quantum-inspired compression techniques that shrink the GPT-OSS 120B architecture down to 59 billion parameters with only 4.8 billion active at inference time, fitting within 40 gigabytes of VRAM using MXF-P4 quantization. The headline numbers look impressive. Configurable reasoning effort levels and the ability to run on consumer hardware like a 3090 paired with a 5060 Ti. But the community benchmarks tell a different story entirely. Independent testing on the Aider coding benchmark revealed Hypernova scoring just 27.1% compared to 62.7% for the original GPT-OSS 120B under identical conditions, a catastrophic 57% drop in capability. More damning still, the percentage of well-formed responses collapsed from 88% to under 40%, with error outputs exploding from 33 to 359. One tester reported that Turkish language competence had degraded so severely that the model can't speak properly anymore, suggesting that compression techniques inflict asymmetric damage across different knowledge domains. As one commenter observed, once density drops below 80% in dense models, they start hallucinating at a very high level, a pattern that appears to hold regardless of whether you call your compression technique quantum or not. More promising work emerged from Alibaba's Tongyi team with MAI-UI, a family of GUI agents spanning 2B to 35B parameters designed for realistic deployment of interface automation. The model achieves 73.5% on ScreenSpot Pro and 91.3% on MMBench GUI L2, surpassing both Gemini 3 Pro and Seed 1.8 on grounding benchmarks. What distinguishes MAI-UI is its explicit acknowledgement of deployment realities, native agent user interaction, MCP tool call integration, and a device cloud collaboration system that routes execution based on task state. The inclusion of online reinforcement learning optimizations for scaling parallel environments suggests lessons learned from actual production deployments rather than benchmark chasing. For practitioners looking to fine-tune these models, LLaMA Factory continues to expand its comprehensive framework with support for over 100 models, including LLaMA 4, Qwen 3, and DeepSeek variants. The ACL 2024 published framework now supports everything from continuous pre-training through RLHF methods like PPO and DPO, with quantization options spanning 2 to 8 bits across AQLM, AWQ, and GPTQ backends. Recent additions include Megatron Core Training backend support and the Apollo Optimizer, making it arguably the most complete open-source fine-tuning toolkit available. Wiggum Agentic Programming Paradigm. A peculiar naming convention has crystallized around a fundamental shift in how developers interact with coding agents. The Ralph Wiggum approach, named after the perpetually earnest Simpsons character who keeps trying regardless of outcomes, represents the codification of a simple but powerful insight. Stop treating language models as one-shot assistants and let them loop until the work is actually done. The technique, pioneered by Jeffrey Huntley, reduces to an almost comically simple bash loop. While, do cat prompt.md, Claude code done. But the simplicity is deceptive. The magic isn't in the loop itself, but in the scaffolding that prevents context rot from turning productive iteration into aimless spinning. Tasks must be bounded, success criteria must be testable, and the agent must know when to stop. As Huntley puts it, Ralph can replace the majority of outsourcing at most companies for greenfield projects. It has defects, but these are identifiable and resolvable through various styles of prompts. What makes the approach work is treating it like sprint planning for a team of one. You spend upfront effort documenting discrete tasks with clear completion signals, typically tests that pass, then let the agent grab tasks sequentially until the backlog empties. Each task starts fresh, avoiding the context window degradation that plagues long-running sessions. One Y Combinator hackathon report described shipping 6 repos overnight using the technique, and Huntley himself claims Ralph is currently building a brand new production-grade esoteric programming language without that language existing in any training data. The philosophical underpinning goes deeper than automation efficiency. Rovin Cohen, who notes his team has been doing this for a couple of years already, long before it had a name, emphasizes that a loop without memory is just motion without progress. The solution lies in structured context, architecture decision records that capture why decisions were made, domain-driven design that provides clear boundaries, and explicit completion conditions. With Claude Flow or similar orchestration tools, the loop becomes an agent that knows where it is, why it is there, and how to move forward. The practical command looks something like Ralph loop, migrate tests to Vitest, run tests, fix failures, max iterations 30, completion promise done. The ceiling on what gets shipped isn't the model alone, it's how well developers manage the feedback loop. Local AI infrastructure and APIs. The gap between cloud API capabilities and local deployment continues to narrow, with this week's standout being a transcription system that challenges assumptions about what consumer CPUs can accomplish. A FastAPI server wrapping NVIDIA's Parakeet TDT 0.6b model in ONNX format achieves 30x real-time transcription speeds on an i7-12700KF, processing 1 minute of audio in 2 seconds, while matching Whisper Large v3 accuracy and offering arguably superior punctuation. The project provides an OpenAI-compatible API endpoint, enabling drop-in replacement for existing workflows including Open Web UI integration. Parakeet supports 25 languages with automatic detection spanning most European languages plus Russian and Ukrainian, and community testing suggests functional support extends beyond the official list with lower word error rates than Whisper for certain languages. The implementation targets Intel CPUs specifically, positioning it as a potential successor to faster Whisper for CPU-bound deployments. For organizations concerned about sending audio to external APIs, this represents a genuinely production-viable alternative. Image generation joins the local API server ecosystem with a comprehensive solution supporting both Qwen Image Edit and Flux 2 Dev models. Version 3.0.0 adds multi-image request support for blending and style transfer, video generation via WAN models in OpenAI API format, and optimized model loading using 4-bit quantized variants like diffusers, FluxBot 2 Dev BMB 4-bit for reduced RAM consumption. The inclusion of intelligent batching and a statistics endpoint suggests maturity beyond hobby projects. For those wanting to orchestrate these local services, an interesting approach emerged using N8N's SH node to maintain stateful sessions with Ollama. The key insight, avoiding REST API calls in favor of interactive CLI sessions preserves context across operations. When generated code fails, N8N captures errors and feeds them back to the same SSH session for automatic correction. A poor man's implementation of the Ralph Wiggum loop using standard DevOps tooling rather than custom agent frameworks. AI decision intelligence and engineering practices. The industry's collective failure to move AI agents from demos to production is becoming impossible to ignore. A striking statistic surfaced this week. 64% of organizations are experimenting with agents, but fewer than 25% have successfully scaled them to production. This isn't a capability gap, it's an engineering gap that requires treating autonomy as a system property that must be designed, enforced, and observed at runtime. The emerging discipline of agentic engineering assumes non-determinism from day one and builds around it. 7 patterns separate constant enterprise failures from functional deployments: bounded autonomy using the smallest permission scope possible, human in the loop as async approval rather than afterthought, prompts versioned as code, evaluation pipelines with golden datasets and automated regression, multi-agent orchestration favoring specialized agents over all-purpose ones, observability via tools like Langfuse and Langsmith, and durable execution where state survives crashes and workflows resume. The microservices revolution is arriving for agent architecture, and MLOps principles now apply to autonomous systems. A more technical constraint emerged from the AI Engineer Code Summit, the dumb zone, that kicks in after approximately 40% of context window utilization. Performance degrades predictably as context fills with massive files, MCP outputs, and meandering conversation history. The remediation patterns include intentional compaction through summarization and fresh starts, research before code workflows where agents explore code bases and compress findings into plans, and sub-agents for exploration that return tight summaries while keeping parent contexts lean. As one commenter noted, the dumb zone is why RAG will outlive long context. External memory beats bloated prompts. Smart retrieval beats unlimited context every time. The challenge extends beyond technical optimization to fundamental questions about representation. In human plus AI decision systems, the queries, data, beliefs, and rules themselves require instrumentation because meaning must be negotiated. When an AI model interprets, "show me yesterday's trades," it silently decides time zone, perspective, and revenue recognition methodology, decisions that can shift meaning by millions of dollars without the user ever knowing. If AI-mediated workflows resolve ambiguity but the trace disappears, trusting agents to act autonomously becomes structurally impossible. Decision traces, explicit records of how ambiguity was resolved, don't compete with decision intelligence but reveal a gap that becomes critical as AI becomes more agentic. Creative AI applications and projects. The synthesis of AI capabilities into creative and specialized applications yielded some genuinely novel implementations this week, none more characterful than Nicolytics Radio, a late-night jazz station for founders who work too late, hosted by an AI DJ who judges you every day with deadpan observations about your inbox and why that proposal is still sitting in drafts. The technical stack reveals careful prompt engineering. 49 artist-specific prompts for Suno music generation optimized for deep work, targeting specific jazz styles from piano trio to tenor ballad with mood tags like soft, warm, slow, lounge, nostalgic. Voice generation uses 11 Labs V3 with a custom clone for fictional DJ Sonny Nicks, a former founder who burned out and now plays jazz for strangers. The script system divides 3-hour episodes into 30 drops, station IDs, bumpers with observations like "the coffee's cold," "you noticed an hour ago, still drinking it," pain points that hit too close, revision 8, "the scope tripled, the budget didn't," and mock ads for services like scope creep insurance. 5 volumes produced 5 days, 70-plus subscribers, and 14K views on the first Reddit post, proving that AI-assisted creative work succeeds when it commits to a specific aesthetic rather than chasing generality. On the more utilitarian end, Project Eris demonstrates how modest local LLMs become powerful when given specific toolsets. Running Mistral Nemo 12B via Ollama on a Lenovo Yoga 7 with 24 GB RAM, the Space Discovery Engine uses the model for contextual memory, reading previous session reports and providing verbal recaps on boot, intent parsing, translating fuzzy natural language into structured FastAPI queries, and anomaly scoring, flagging spectral signatures that don't fit standard star-planet profiles. The Tory Rust backend calling Ollama's API exemplifies how constraining a model's domain amplifies its apparent intelligence. Perhaps most charming, an M5 Stick C+2 Pocket Assistant built for an 8-year-old without a phone, sub-$20 hardware that records 5-second audio clips, queries OpenAI, and responds in 20 words or less. The child asked 66 questions over a few days at a total cost of $0.66, revealing more about children's relationship to AI constraints than any academic study. They adapt quickly, and the questions they ask illuminate expectations adults might not consider. AI tools and user interaction. A deceptively powerful pattern for improving AI-generated code emerged from Claude Code users, the Ask User question tool applied to requirements gathering before implementation begins. The technique involves prompting the agent to read a specification file and interview me in detail using the Ask User question tool about literally anything: technical implementation, UI and UX, concerns, trade-offs. Continue interviewing me continually until it's complete, then write the spec to the file. The results reportedly justify the patience required to answer 40 to 50 questions for larger projects. Users describe receiving polished local apps that minimize technical debt because the agent had sufficient context before writing code. One example: as the tax documents start rolling in, I want a sandbox tool to save and query the documents with a local LLM, led to a finished application that tags, summarizes, and enables semantic search using natural language embeddings. Combined with the front-end designer plugin, the approach saved hundreds of hours, according to practitioners. The pattern addresses a fundamental mismatch. Developers know what they want, but communicate it incompletely, while models excel at structured interrogation but receive insufficient context. By flipping the interaction, letting the model drive requirements gathering rather than passively accepting specifications, the resulting code artifacts require fewer iterations. The tool nails the questions because it systematically covers implementation details that humans omit when describing features. Its requirements engineering automated, with the side effect of forcing developers to articulate constraints they might otherwise discover only through debugging. Technical infrastructure and security. For developers entering GPU-accelerated ML work, a comprehensive guide emerged that demystifies what practitioners actually need to know to move beyond high-level framework calls. The author's journey began when improving model flops utilization for training jobs revealed that understanding GPU internals was essential, particularly after implementing flash attention without grasping the underlying principles. The guide introduces what it calls the pentagram of performance bottlenecks. Compute-bound workloads hit fundamental T-flop limits that only hardware upgrades can address. Overhead bottlenecks, particularly eager execution mode in PyTorch, where GPUs idle while Python dispatches CUDA kernels, can be addressed through CUDA graphs that reduce dispatch time. Input-output bottlenecks from slow storage explain why long training jobs pre-tokenize data. Network bandwidth constraints in distributed training motivate techniques like DiLoco that reduce communication frequency. And memory bandwidth, the dominant bottleneck for many LLM workloads, determines whether operations are compute-bound or memory-bound based on arithmetic intensity. The practical implications. H100 GPUs achieve 1,979 T-flops at FP8 precision, but only 3.35 TB-second memory bandwidth, meaning most transformer operations during inference are memory bandwidth limited. This explains why flash attention matters. It's not about faster math, but about reducing memory traffic through operator fusion. The author argues that even as LLMs become capable of writing systems code, researchers need deep GPU understanding because LLMs perform much better when guided by someone who understands the problem, and coding agents remain more augmentation than autonomy. On the security front, an intriguing cryptographic innovation repurposes passkey infrastructure for use cases beyond authentication. Passseeds exploits a subtle property. Even public keys in passkey bundles behave like hardware-secured, synced secrets because the system never exposes them if you avoid storing them at generation time. This enables deriving cryptographic material for curves passkeys don't natively support. CP256K1 for Bitcoin, BLS 12381 for zero-knowledge proofs, while inheriting the hardware security and cross-device sync that makes passkeys usable. Section: Miscellaneous Tech News. The most instructive story this week wasn't about new technology, but about the failure modes of information verification in an AI-saturated environment. A Reddit post from Throwaway Whistleblow claiming insider knowledge of food delivery app fraud accumulated 86,000 upvotes and over 36 million views on X before being exposed as an elaborate hoax. The alleged whistleblower described systems calculating desperation scores for drivers, deliberately slowing standard deliveries to make priority orders appear faster, and systematically grinding full-time drivers while reserving good tips to gamify casual driver experience. When journalist Casey Newton began verification, red flags accumulated quickly. Frequent spelling errors in direct communication that were absent from the polished original post, an AI-generated employee badge that looked plausible, and an 18-page fabricated technical document titled AlecNet-T, High-Dimensional Temporal Supply State Modeling, complete with charts, diagrams, and confidential watermarks. The hoax succeeded precisely because it told a story people wanted to believe about algorithmic exploitation, leveraging AI tools to manufacture supporting evidence. More practically useful, GNU Rescue 1.32 brings significant improvements to data recovery workflows, particularly for drives with dead heads. The update improves automatic recovery by orders of magnitude. All recoverable data from a 1 terabyte drive with one of 4 heads dead can now be recovered after 283 read errors instead of 3,782,794. The new sweeping phase replaces Pass 5 and no sweep allows disabling reading of skipped areas. The changes mean an unexperienced user can now achieve results that only an expert could achieve with the previous version. In AI security tooling, EVA emerged as an AI-assisted penetration testing agent supporting multiple backends including Ollama, OpenAI, and custom endpoints. The tool guides users through complete pentest engagements with AI-powered attack strategy, autonomous command generation, and real-time vulnerability analysis, explicitly positioning itself to guide and assist rather than replace security professionals. And FlowToGAN offers a novel two-stage framework for few-step audio generation, combining flow matching improvements with lightweight GAN fine-tuning, achieving one-step generation with quality matching or exceeding state-of-the-art methods through endpoint estimation reformulation and spectral energy-based loss scaling.